In this question, we're given the enthalpy of a reaction where two mercury 2 oxides are reacted to form two mercuries and oxygen gas, and the enthalpy of the reaction is positive 182 kilojoules. Since this is positive, it means that the reaction is endothermic. And the first question it asks is whether or not the reaction is endothermic or exothermic. If delta H is positive, the reaction absorbs energy, heat energy, so therefore the reaction is endothermic. If delta H is negative, then it releases heat energy, which makes this exothermic. But since it's positive, it's endothermic. The next thing to remember that's really important is that the enthalpy of the reaction is for the reaction as written. So this is for the reaction of 2 moles of mercury 2 oxide. So if we react 2 moles of mercury 2 oxide, 182 kilojoules of energy will be absorbed. So now it says, suppose 86.7 grams of mercury 2 oxide react. Will any heat energy be released or absorbed? Yes, if any amount of mercury 2 oxide is reacted, heat energy, will be absorbed because delta H is positive. In the last question, it asks us to calculate the exact amount. To do that, we need to do something that's very similar to stoichiometry, except at the end of the day, we're going to get energy instead of maybe grams or moles as our final answer. So first of all, with a plan of attack, we want to go from grams. In this case, we have 87.6 grams of mercury 2 oxide, but we want to go from grams of mercury 2 oxide to moles of mercury 2 oxide, and then finally to kilojoules. The gram to mole equality we're all very familiar with. So we can look up mercury on the periodic table, look up oxygen, and what we'll find is 1 mole of HgO equals 216.59 grams of HgO. The next equality is new, but it's based on the enthalpy of the reaction. So if we want to go from moles of mercury 2 oxide to kilojoules, we have to look at the balanced chemical equation. The kilojoules are the enthalpy of the reaction. The moles are the stoichiometric number of moles, because this is for the reaction as written. So 2 moles of HgO is equal to 182 kilojoules of heat energy being absorbed, because that is the enthalpy. Now we can do the dimensional analysis, starting with 87.6 grams of HgO times, we want to convert to moles, grams to moles, so we want to put moles on the bottom, grams on the bottom, 216.59 grams of HgO. That'll make grams of HgO cancel out. 1 mole of HgO on top. For the next conversion, we want moles of HgO to cancel out. So we put our 2 moles from the balanced chemical equation, HgO on the bottom. So 2 moles gives the 182 kilojoules. So we put the 2 moles on the bottom and the 182 kilojoules on top. When we do that math, we get 36.85607 and some more numbers kilojoules, but we want to round that to 3 significant figures since our original mass had 3 significant figures, which is 36.9 kilojoules. This is the amount of heat energy that is absorbed when we react 87.6 grams of mercury 2 oxide according to this enthalpy information given above.